Welcome students, get ready to solve my June 2025 paper 2 variant 2 of 5054 paper with TPS. So in this paper, you remember that you have to take the value of G, that is going to be 9.8 Newton per kilogram. So total marks are 80 and we have to attempt all the questions. So let's see the first question. A ball is dropped from the height, you can say ball is dropped by the side of a vertical scale that is marked in centimeter. So suppose here you are having a scale, meter rule you can say, and ball is dropped along this. So a video recording of the fall shows the position of the ball on the scale every 0.1 second. So time is given and the time is 0.1 second. So the distance the ball falls is shown by the position on the scale because meter rule is used to measure distance. You can see meter rule or scale, vertical scale, ये बेटे distance measure कर रहा है for every time of 0.1 second. Table is given. Table shows the result that for 0 second, distance is 0 centimeter, time is in second. So when 0.1 second is passed, distance is 5 centimeter. When it is 0.2 seconds time, the distance is 20. So distance is increasing non-uniformly. So this thing is indicating that speed is increasing. Speed is increasing non-uniformly. So moving forward, A part is on figure 5.1, plot the distance time graph for the ball, draw a suitable line. So this data is given to us. We have to use this data to plot the graph. So on the horizontal axis, on the horizontal axis, each interval is of 0.1 second. Each interval is of 0.1 second. You can see total interval is of 0.6 seconds. And on vertical axis, we are having an interval of 20, then again 20. So total distance which is given here, it is 140 centimeter. So uh, here we have to first of all divide this, that how much one box is representing. One small box is equal to, you can see the gap divided by number of boxes. So gap is 20. बेटे ये gap आप नोट करें और उसको number of boxes से क्या कर दें, divide कर दें. You will get 2. Means one small box is representing to 2. So where is going to be 5? It will be 2, 3, 4, and it is somewhere here. And then we have another value. This point is going to be here. Then for 0.2, the distance is 20. So this point will be somewhere here. So remember, students, always draw cross. You have to draw the cross for the point. For points, you have to draw the cross. If you are not drawing the cross, you can draw a circle or a point and draw the circle around it. In this way, you have to mark the points. क्रॉस लगा सकते हैं या डॉट लगा के उसे सर्कल कर लें. At 0.3, you are having a distance of 44. So 0.3 and we move towards 44, so it will be somewhere here. Then we have 0.4 and the distance is 78, so 0.4. So here we have 80, so I am going to mark here because one small box is representing to 2. Then moving forward, at 0.5, the distance is 123. 0.5 is here So distance is 123. So it will come somewhere here. So now you have to join these points. So this thing is indicating that it will be a curve. And you can see speed is increasing non-uniformly. I told you from this data, इस टेबल से पता चल रहा है इस वैल्यूज की कि डिस्टेंस जो है वो इंक्रीज हो रहा है नॉन यूनिफॉर्मली सो स्पीड इज इंक्रीजिंग नॉन यूनिफॉर्मली सो इट विल बी अ कर्व्ड ग्राफ so now I am going to plot it. I try my best to draw a best line here. So it will be somehow like this, like this, and this. So hope so this is clear. Moving to next part, part number 2. Calculate the average speed of the ball between time 0 and time 0.4 seconds. So average speed is what? Average speed is total distance traveled divided by total time taken. So total time taken is 0.4 and total distance traveled you can see from the table it is 78. So we are going to divide these two values. You will be getting average speed. So let me calculate it. 78 divided by 0.4, I am getting 195. So be very careful that it is in centimeter per second, so no need to convert the units. Moving to part 3, describe how to use the graph in figure 1.1 to determine the speed of the ball at time this. So this time in this part they are asking for speed at time 0.4 second. So this is a curved graph. It is a curve. So in curved graph, you have to draw the tangent whenever it is distance time graph. Whenever it is distance time graph, you have to draw the tangent to find the speed. To find the speed and then find its gradient. You have to find the gradient. बेटे आपको gradient find करना पड़ेगा after drawing a best tangent here. So we have to draw the tangent here at 0.4 and then take points from there and find the gradient. So I will be writing here that the word is describe. You have to write the words. So what you are going to do, draw a tangent line at time 0.40 seconds, then find its gradient. You will be getting the speed. So moving forward, B part, as the ball falls, the acceleration of the ball decreases. It means value of A is decreasing, eventually becomes 0 and after decreasing it becomes to 0 यानी पहले acceleration decrease हो रहा था और फिर उसके बाद क्या होगा it becomes 0. So there are two stages before it reaches the ground को touch करने से पहले. So explain in terms of forces acting why the acceleration decreases and why it eventually becomes 0. So why it is decreasing we have to tell in terms of forces. हमने forces की form में बताना है और why it becomes then 0. So remember ball is here. Ball is having some weight which is acting downwards. And when I drop the ball from here, what happens? Its speed increases. Its speed increases. When speed is increasing, air resistance increases. Air resistance increases. Air resistance is acting in opposite direction. So it means your resultant force decreases. Resultant force decreases, if resultant force decreases, you know F is equal to ma, mass is constant of ball. So if force resultant is decreasing, acceleration will decrease. And a time will come when ball weight and air resistance become equal. When weight and resistance become equal, then resultant force will be zero and acceleration will be zero. So you have to write this here, that when ball drops, its speed increases. Due to this, air resistance increases. Air resistance increases. Air resistance increases. So resultant force decreases. Therefore, a time will come, a time will come when weight of the ball, weight of the ball and air resistance become equal, then resultant force will be zero, so acceleration will be zero. Acceleration will be zero. I am writing here on the tab, so it is taking too much space and the writing is too big. So when you are going to solve it on the page, I hope so it takes less space. These lines are fine. So moving towards part 2, describe the appearance of distance time graph when the acceleration of the ball is zero. Means how the graph looks, how the graph of distance time looks, means appearance means looks, when acceleration will be zero. So dear, distance time graph give us zero acceleration when gradient is constant. Acceleration will be zero when gradient is constant. Gradient is constant, it means speed is not changing. So it will be possible when the graph somehow looks like this. If I draw here, time is here, distance is here in centimeter, or you can take in meter. So if the graph is straight line, if you find its gradient, it will be constant, gradient will be constant, and acceleration will be zero. So I will be writing here, it, it will be a straight line graph, or you can say gradient is constant. Even you can say this thing, that gradient is constant. So hope so this question is understandable by you. It is a 10-mark question. So moving to question number 2. In question number 2, figure 2.1 shows fork lift truck. This is forklift truck used to lift a load. So when lifting the load, electric motor on the forklift truck has a useful output power. So this is given to us, useful output power, that is 600 watt. So define power. So here you have to write the definition. So what it is going to be, work done per unit time, per unit time, because P is equal to W by T. So moving forward to B part, the efficiency of the motor is given, that is 70%. Calculate the input power. So you have to remember the formula of efficiency, that is equal to, efficiency is equal to output power divided by, so I will be writing here useful output power, not wasted. Sometimes we have to be very careful because wasted power is given, so we have to find the useful one. So useful output power divided by total input power. So it will be 70 divided by 100, because percent is equal to 1 over 100, which is equal to 600 watt divided by input power. I am writing P in for input power. So we have to do some manipulation. P in is equal to 600 multiplied by 100 divided by 70. So this 0 cancel with this. So I'm left with 6,000 divided by 7. So let's calculate 6,000 divided by 7. It is 857.14 watt. Hope so this is clear. You can round this value to 860 as well. Now part number C, the forklift truck lifts a load with mass of 50 kg through a vertical distance. So it means this is a mass, you can assume it is lifting in the upward direction. Its height is 2.3 meter. So work done in lifting the load. So its mass is given, that is 50 kg, and weight will be W is equal to mg. Weight is going to be force here, because work done is equal to F multiplied by D. So mass times 9.8. So it will be for 50 times 9.8. It becomes 490 Newton. So we have to substitute the values here. 490 multiplied by 2.3. 490 multiplied by 2.3 gives 1127 joules, or you can say joule. So moving towards next question, calculate the time taken to lift the load. Time taken we have to find. So you know output power, and you know output power will be equal to work done divided by time. So time is equal to work done divided by output power. Why we are using output power? Because time taken to lift the load. So you have calculated work done, that is 1127 divided by 860. So you will be getting the result, that will be 860. It will be 1.3 seconds. Hope so this is clear. Now we have last part of this question, part D. Describe how energy is transferred to thermal energy as the load is lifted. So when load is being lifted, जब इस लोड को बेटे उठाया जाएगा, लिफ्ट किया जाएगा, so air resistance is there, air resistance will be there, or you can say motor is working. When motor is working, friction will occur. When friction occurs, it means thermal energy. Energy is converted to thermal energy, or motor is working against gravity, or you can say resistance. So friction is there. So it is going to be due to friction, the thermal energy, or you can say when motor is working, charges are there. So electrical energy is possible, due to charge is possible. So I'm writing here friction, because it is a 1 mark question. I will be writing here that due to friction, due to friction. So moving next, figure 3.1 shows a flat tire on a car. You can see this puncture tire. It is representing to puncture tire, that is this one flat tire. The tire needs to be inflated. So A part is saying the force exerted by the flat tire on the road. Here the force is given, that is 1350 Newton. The area of the flat tire which is in contact with the road that is given. You have to calculate the pressure by the flat tire on the road. So pressure is equal to force divided by area. So 1350 divided by 0.007. So you will be getting the pressure. 1357 divided by 0.007. So it will be 192,857.14. So I'm going to convert this into standard form. 1, 2, 3, 4, 5. 1.9 times 10 power 5 pascals. So moving to part 2 of part A, air is pumped into the tire to inflate it. You can say it means air is filled the tire. ठीक है जी? Means air is going to be filled in the tire. This increases the pressure inside. The force exerted by the tire on the road does not change. Force is not going to change because of, you can say, some pressure, air pressure, and you can say everything is same, structure is not changed, so force is not going to be changed. So state how the area of the tire in contact with the road changes. So you know pressure is equal to force over area. If pressure increases, if pressure increases, it means area is less in contact with the road. So less area is in contact with road. You can write even area decreases. Area decreases. So moving forward, inside the inflated tire, a particle of air collides against the wall of the tire. So air collides, okay, define momentum. Okay, you can see if I draw a shape of tire, so somehow this is the tire. Here we have air particles. Suppose this particle go and collide with the wall. After collision, it changes its direction. If it changes its direction, it means velocity changes. Velocity changes. If velocity changes, it means change in momentum is there. So anyhow, we are going to state define momentum. So momentum is product of mass and velocity. So in part 2, using ideas about momentum, explain why there is force on the wall of the tire as the particle collides. So you can see the particles are going to collide. I have drawn this picture. ये picture मैंने एक टायर की बेटे बनाई है. You can see here the particles are colliding with the wall of the tire. So when they are colliding, there is a change in momentum per unit time. Change in momentum per unit time, which is representing that force is there. So we will be writing this because F is equal to change in momentum by time. So Newton third law is also applicable. Newton third law, because air is going to exert force on wall and wall will also exert same force in the opposite direction. So why there is force on the wall of the tire as the particle collide? So you can write here change in momentum per unit time will occur change in momentum per unit time will occur. So it is creating force and wall is also exerting force in opposite direction. So Newton's third law holds. Third law is applicable. Hope so this is clear. Moving to next. As the car moves, the temperature of the air inside the tire increases. Means movement, or you can say collision of the particles, gas particles increases. When air particles are going to collide, might be temperature increases. So anyhow, the temperature of the air inside the tire increases. The increase in temperature causes an increase in the pressure of the air. So using ideas about particles explain why pressure increases. So you know temperature increases as the statement is written, and pressure is going to increase. So pressure is directly proportional to temperature. When temperature increases, collision increases because speed increases. Speed increases. If speed increases, kinetic energy also increases because kinetic energy is equal to 1 over 2 mv square. So we are going to write this, that is, as temperature increases, speed of particles, air particles increases, speed of particles increases, due to which kinetic energy increases, therefore pressure increases. Pressure increases. I hope so this is clear. We are done with this question. Moving to next question. Question number 4. A sound wave from a vibrating tuning fork is displayed on the oscilloscope. In figure 4.1 you can see this. The sound wave is detected using a microphone. Beta, you can see here, this is a tuning fork. Vibration is going to occur here at these ends of the tuning fork. When these vibrations are going to occur, what happens? Fork is going to be somehow like this. It means compression in the molecules occur. And when it come back like this, or might be little bit like this, so it means rarefaction is going to be there. Rarefaction is going to be there. So molecules which are in the surrounding of the tuning fork, somewhere here, they are going to have to and fro motion here. To and fro motion here. Or you can say backward and forward motion of air particles. And as these air particles are detected by a microphone, what happens? Wave is going to be created on the oscilloscope. So the A part is saying, describe the motion of air particles as the sound wave passes from the tuning fork to the microphone. So whatever I was explaining in the diagram, you have to describe here. So I'm going to write the wording here. बेटे compression हो रही, rarefaction होगी, और you due to this to and fro motion create होगी, और air particles same direction में move करेंगे जिस direction में vibration है. तो माइक्रोफोन जैसे ही डिटेक्ट करेगी उसको, तो माइक्रोफोन एक ऑसिलोस्कोप पर वेव क्रिएट कर देगा. So what we can write here, sound is created, or sound from the fork is due to and fro motion of air particles in the direction of sound wave traveling. So this is the answer for this. So moving to B part, figure 4.2 shows the trace seen on the oscilloscope when the tuning fork vibrates. Tuning fork, when it is vibrating, you are looking to this oscilloscope, the same wave is given to you here. So how many waves are created? From here, if I note down, till here it is one wave, second wave, and this half. So 2.5 waves are there. In how much time? In time 0.05 second. So if I want to find time for one wave, we can find by 0.05 divided by 2.5. So we will be getting the time for one wave. So it will be 0.02. So the question is, the frequency of the sound is constant, frequency is not changing. State what is meant by frequency. So frequency is number of waves, or you can say oscillations, vibrations passed per second. So moving to next part, the trace shown on figure 4.2 is produced in this much time. So calculate the frequency. Okay, you know frequency is equal to 1 over t. So we have calculated the time here for one wave. So 1 divided by 0.02. If I calculate this, you will be getting the frequency that is going to be 50 hertz. So moving forward, actually I have already done this. So it is good practice when you make some clear picture that what is going on here. मैंने ये पहले ही एक पिक्चर बना ली थी कि एक वेव को कितना टाइम लग रहा है. So moving forward, we have part 3 here. A student near the tuning fork observes the trace and listens to the sound. He notices the amplitude of the trace decreases. If amplitude is decreasing, it means loudness is decreasing. Yeah, they are asking state how the sound heard by the student changes. It means loudness is decreasing. Voice is low, you can say. So amplitude is directly proportional to loudness. Remember this. It is not dependent on frequency. Loudness is not dependent on frequency. Hope so this is clear. Now we have next part, the tuning fork is replaced by new tuning fork that produces a sound wave of half frequency. Half frequency. Okay, frequency is now, you can say, 25 hertz. Previously we calculated it 50, or you can say it is now half of previous frequency. So the control on the oscilloscopes are not changed, means time base is not changed, amplitude is not changed. On figure 4.3, draw the trace obtained with new tuning fork. So if frequency decreases, it means number of waves also decreases. So in this diagram, if you are getting one wave in this time, now you will be getting half wave in this time period. So I'm going to draw somehow you can say this much half wave you are getting. So rest of the cycle is also going to be same. It will be coming to this point. Amplitude is same, only frequency is changed. So it will go till this. So half waves, one point you can say 2 5 waves are there. So we are done with this part. Now the part C, figure 4.1 shows three adjacent wave fronts. These are the wave fronts. They are always perpendicular to energy transfer. Remember this. They are always perpendicular to energy transfers, wave fronts. So these wave fronts are for the sound wave. As the wave front moves towards a gap in a wall created by an open door, so this is a gap here. So you can compare that wavelength is greater than gap. Here we have a wavelength. So another student standing at P here on the wall, on the other side of the wall, hears the sound. On figure 4.4, draw three wave fronts after they pass through the gap. So wavelength is greater than gap, so we will be having circular waves, circular wave fronts, sorry. Whenever the gap is greater than, wavelength is greater than gap, so we are going to draw circular wave fronts. If wavelength is less than gap, then less curvature will be there for the wave front. So we are going to draw the waves here. This is going to be one. And whatever this wavelength is here, same wavelength is going to be considered here. So here I am having another wave, then another wave of same wavelength. So we are going to draw like this. So moving towards next, part 2, state the name of the process involved as the wave fronts pass through the gap and reach the P. So this is basically a process of diffraction. So we are done with this question. So moving towards next question number 5. So we are moving to question number 5. Question number 5 is a student sets up the circuit shown in figure 5.1 to measure the resistance of a length of wire. The circuit contains four identical cells. Four cells. So this is one, this is second one, then third and fourth. So here is difference between these cells. So let's see. The student finds that both meters read 0 when switch is closed. When this switch is going to be closed, the meters are giving 0 value. Nothing is going to be there. This is because the circuit shown in figure 5.1 is not suitable for the measurement. So there is a problem. So we have to identify that. The very first thing is that these cells are connected in series, but their polarities are opposite. They are connected in, you can say, opposite order. So its negative polarity and this negative polarity is connected. तो हमें ये क्या करना पड़ेगा एक सीक्वेंस में पॉजिटिव नेगेटिव वी हैव टू कनेक्ट these in a series, that the negative of one, the positive of next, then negative of next cell, then the positive in this sequence. So we have to, you can say, reverse the order of any one, either this one or this one. So another thing is that voltmeter is not connected in series. Voltmeter is connected across the component. So this is another problem. So we have to replace these two. Then this circuit is suitable for the measurement. So A part is describe all the changes to the circuit that are needed so that the meters produce readings that can be used to calculate the resistance of the length of wire. This is the length of wire. We have to calculate the resistance of this. अब इसकी resistance find करने के लिए you must know voltage and you must know current. So to find the current, ammeter should be connected here rather than voltmeter. Ammeter is connected in series. Ammeter is connected in series. Ammeter in series. And voltmeter should be connected here. Voltmeter is connected across the component. Voltmeter in parallel to the component. To the component. One thing. Second is that we have to reverse the polarities. Reverse the polarities. So this is what you have to describe here, the changes which are required. So I would say that you have to swap these meters. So you can say swap or you can say swap. Swap the meters with each other, with each other's position. One thing. Second is you have to change the polarities. So either you have to change the polarities of this or the cells connected here. So it is better to change this because here we have a variable component, variable resistor, so positive and in this way. So I would say that reverse the polarities of two cells, two cells. Okay. In such a way, in such a way that they come in sequence. In sequence. So moving to next part of this question, B part. Figure 5.2 shows the current voltage graph for a 9 centimeter length of wire line P. Okay, here we have line P and this graph is indicating current voltage graph, and the length of this wire is 9 centimeter. And for a different length of the same wire with cross sectional area and same cross sectional area, line Q is shown. So it means length of same wire for a different length. Okay, not same. Wire is of same means material is same. Material is same, area is same, but length is different. Okay, this line Q is having different length. So moving towards this, we have to find here the calculate the resistance of the 9 centimeter length of wire. We have to find the resistance for this. So we are given with current voltage graph. You know R is equal to V over I, and when we are given voltage current graph, and if we find gradient, we get resistance. But here we are given current voltage graph. So if we find gradient, we will be getting reciprocal of resistance. Reciprocal of resistance. So this thing is very important here. So what I do, one thing is, if you are going to find the gradient, keep the voltage in the numerator and keep the current in the denominator. Then no need to take the reciprocal. If you are taking current in the numerator like this, I over V, then it is important to take the reciprocal because you are not going to get R, you will be getting 1 over R in this case. So it is important you are basically finding the gradient. So I take one point this and other point is this. So here I am having 6 comma 0.8 and here I am having origin, that is 0 0. So what I do, R is equal to 0.8, this is the current, minus 0 divided by 6 minus 0. So here I am doing what? Basically R is equal to I2 minus I1 over V2 minus V1. Sorry, this is going to be 1 over R. This is going to be 1 over R, reciprocal of resistance. This is one way. The other way is if I take R is equal to 6 minus 0 and divided by 0.8 minus 0, then it is going to be perfect. No need to take the reciprocal. So 1 over R is equal to, if I divide 0.8 divided by 6, I am getting 0.133. So now I take the reciprocal here. It will be R is equal to 1 divided by 0.133. It will be 7.5 ohms. So this is important here. This is a critical point. What I did, I take R there and swap the values here basically. Cross multiplication. If I do this procedure by keeping in mind कि ये मेरे पास gradient देगा, if you keep in mind that gradient is going to be voltage divided by current, then no need to take the reciprocal. 6 divided by 0.8, you will be getting straightforward 7.5 ohms. So hope so this is clear. Moving to next part. Explain whether line Q is obtained with a length of wire that is longer or shorter than 9 centimeter. So we have to explain here that the line Q is having the shorter length of wire or longer length of wire. सिंपल इज दैट हमने ये सिर्फ बताना है कि लाइन क्यू की लेंथ जो है it is smaller or greater, simply. So it's very important what you have to do. You know resistance is directly proportional to length. Resistance is directly proportional to length. So you can see its its gradient will be smaller. Why I'm saying gradient will be smaller? It is current voltage graph. If you take its reciprocal, it will be getting a smaller value. Gradient will smaller. If gradient will be smaller, it means resistance is smaller. If resistance is smaller, it means length will be shorter or smaller. So you can find by taking the points here for your own, but we are going to explain here whether line Q is obtained with a line length of wire that is longer or shorter. So I would say length of wire Q is shorter because resistance is smaller. In other words, one more thing you can add here. If you see for 4 voltage, for 4 volts, you are getting less current, and for 4 volts you are getting more current. So R is equal to V over I. If we keep this voltage constant 4 volt and we divide it with different currents, so smaller the denominator. If I am having this current, this is smaller current, the value of resistance will be greater. If I divide with 0.8 ampere, means R is equal to V over, with larger current, I will be getting smaller value. R will be smaller. If R is smaller, length will be smaller. So you can relate here with current as well. So both are correct. Now here we have to calculate the length of wire used to obtain line Q. Used to obtain line Q means in simple words, a length of wire Q we have to find. So we know R is equal to rho L over A, and in this question, in this part, area and this resistivity of the material is same, area is same, so we can use this directly, that R directly proportional to length. So we know resistance of wire P, we know resistance of length of wire P, we know resistance of wire Q, and what we know we have to find the length of Q. So we can use ratio method as well. Ratio method as well. So what it will be, RP divided by RQ is equal to LP. It will be LP divided by LQ. So we can use the resistance, that is 7.5. We can find the resistance of Q here. Yes, we can find by taking the gradient of this. So it will be 4 comma 0.8, and this is origin. So resistance of, I think somewhere it is given, might be resistance of Q. No, I think no. So resistance is going to be Q is equal to, I have to take voltage above and 0.8. So if I calculate, I will be getting 4 divided by 0.8, it will be 5 ohms. So using this ratio, what we can do, we can find RP was 7.5 divided by 5, length of wire P is 9, we have to find for this. So if you simplify this, you will be getting LQ is equal to 9 times 5 divided by 7.5. So it will be, if I calculate, divided by 7.5, so I'm getting this 6 centimeters. So this is going to be 6. So we are done with this question. Moving to question number 6. In this question, figure 6.1 shows part of main circuit that includes 3 lamps and a heater. So you can see here 3 lamps are here, lamp type B, lamp type Q, and this is the heater. So what we have to do in A part, you can see the mains voltage is 230 volt and the power of the heater is 2000 watt. Okay. So this is a parallel circuit. It is a parallel circuit. So 230 is here in the main. So 230 will be in this branch, 230 volt will be here, 230 volt will be in this branch, 230 volt will be here. So it is a parallel circuit. So fuses are also given in this circuit. This is a lighting circuit. Fuse means this fuse is controlling this circuit, and this heating circuit fuse is controlling the heater. Okay. So fuse is basically going to control how much current rating can flow from there. So if there is a fuse, there is a 5 ampere fuse in the lighting circuit. 4 fuses of different ratings are available for use in the heating circuit shown in the list. So you have to underline the most suitable one. Most suitable one you have to underline here. Okay. So the statement is, underline the most suitable fuse value for heating circuit fuse and explain your choice. Your answer must include the calculation. So available fuses are 5 ampere, 8 ampere, 13 ampere, and this one. So this is 5 ampere. So what we can do, we can use the formula of power. Power is equal to VI. Power is equal to VI. For the calculation, power is equal to power is equal to VI. I know voltage, that is 230 volt. I know current. No, I know power. So that is 2000 watt. I can find current. So I is equal to T divided by V. So 2000 watt divided by 230. If you divide this, you will be getting the current. 2000 divided by 230. Okay, I am getting it 8.69. I can take approximately 8.7 ampere. So this is the calculation. So we have to tell that underline the most suitable fuse value for the heating circuit fuse. Heating circuit fuse. Okay. We have to tell about this. That how much rating of this fuse should be. So remember, whenever there is going to be a current 3 ampere which is going to flow, keep the fuse rating fuse rating should be higher than the given higher than the flow of current higher than the flow of current. Actually, what happens if 3 ampere current will flow and you are using 3 ampere fuse, it will burn, it will blow, it will melt. So it is not appropriate. We can bear this 3 ampere current. So it is better to keep little higher. You can use 5 ampere. This is a good suitable way, good appropriate way of using the fuse. So we are getting 8.7. So we should keep little higher. We can't use 8 ampere. Here the rating is given. 5 ampere is not suitable. 8 ampere is also not suitable because when 8.7 will flow, this fuse will melt. So it is better to keep 13 ampere. This is going to be the best one, 13 ampere. We are not going to use 5 ampere. We are not going to use 8 ampere. We are going to use 13 ampere. So I will underline this. We can't use 30 ampere as well because it is too much. Because if 20, 19 or 20 or 21 ampere current will flow, it will damage the heater. It will damage the heater, but fuse will not melt. It will not melt, so it is not suitable. तो बेटे याद रखना है हमेशा जो भी फ्यूज आपने यूज करना है उसकी रेटिंग करंट फ्लो से थोड़ी सी क्या होनी चाहिए, ज्यादा होनी चाहिए. So what I explanation I would give here, that fuse rating fuse rating needs to be little spelling mistake, need to be little higher than the normal flow of current than the normal flow of current. This is going to be the answer. So this next part B, describe what happens to a fuse when the current is too large. So what happens? It melts. Fuse will blow when more current than its rating will flow. Then its rating will flow. जो उसकी rating है उससे ज्यादा जब current flow करेगा, it will blows. So moving to next part, Table 6.1 shows the current in lamps of type P and type Q when connected to main supply. So here we have current and the type of lamps. Calculate the current in lighting circuit fuse. Current in lighting circuit fuse when all the three lamps are switched on. So if you go to the circuit, we have to find the rating of this fuse. So what we know in the table, we are given that lamp P is having 0.26 ampere, 0.26 ampere, 0.26 ampere, and 0.43 ampere. So it is a parallel circuit. When switch will be closed, the current which is going to flow here, it will split here, IP, IP, and IQ. So if we add these currents, we will be getting the fuse rating. So here actually what we have to do, I is equal to IP plus IP plus IQ. So let's add. So it will be IP plus IP plus IQ. You will be getting the current. So it will be 0.26, 0.26 plus 0.26 plus 0.43. You will be getting 0.95 ampere. The rating of the for the lighting circuit fuse is 5 ampere. The lamp of type Q is removed from the circuit. So what we have to do here, that the circuit rating is 5 ampere, the lamp of type Q is removed. So you have to calculate the maximum number of additional lamps of type P that can now be connected in parallel to the lighting circuit. So number of additional lamps we have to basically calculate. So two are already connected. We are going to remove this lamp, and in place of this we have to connect lamp type P, lamp type P having the current rating this. So according to this 5 ampere fuse, we have to see how many lamps can be adjusted. हमें 5 एम्पेयर करंट रेटिंग फ्यूज की गिवन है। हमने चेक करना है कि आगे हम कितने लैंप्स लगा लें कि ये 5 एम्पेयर फ्यूज जो है ये को रन कर सकेगा। So what we have to do, we know 5 ampere current and we know rating of uh, lamp P, lamp P that is 0.26. So we will divide this 0.26. We will be getting a number of lamps. We will be getting number of lamps because we know total current flowing from it and how much current one lamp will take. We know this. So we will be dividing it 0.26. So the answer is 2.9.23. So it should be less than this. It should be less than this because 5 ampere should be the maximum one. So it should be less than 5 ampere. So I'm going to take it 17 because two lamps are already I'm having. So 219.23 minus 2, I will be getting 7.23 ampere. So it is 7.23 ampere. So we will be taking 17 rather than 18. So this is number of additional lamps। एक्चुअली हुआ क्या है यहाँ पर, हमारे पास लैंप पी की रेटिंग गिवन थी, टोटल करंट जो थी उस फ्यूज जो जिसमें से फ्लो कर सकता है करंट वो 5 एम्पेयर था। अब हमने 5 एम्पेयर टोटल करंट को एक लैंप की करंट रेटिंग से डिवाइड किया, हमें ये एक रिजल्ट मिल गया नंबर ऑफ लैंप्स का। अब टू लैंप्स टाइप पी के टाइप ऑफ लैंप पी ऑलरेडी कनेक्टेड हैं टाइप पी लैंप्स, तो वो मैंने सब्ट्रैक्ट कर लिए हैं यहाँ से एंड आई एम गेटिंग 7.23। तो मैं एग्जैक्ट इतने लैंप्स तो ले ही नहीं सकता, आई विल बी हैविंग वन लैंप टू लैंप इन दिस वे इन इंटीजर्स, 0.23 लैंप हो नहीं सकता। तो सो आई हैव टू टेक लेस देन दैट, सो आई एम टेकिंग 17। So in some houses The lighting circuit is protected by trip switch, which is also known as circuit breaker, instead of fuse. So when fuse melts, you have to replace it. This is a problem. When the circuit breaker is going to trip, you are not supposed to buy new. No need to buy new. So what are the advantages? One I have told you. So you can write when current will fluctuate, or you can say when current will differ. Okay, rather than differ, we will be saying vary. When current will vary, then trip switch will become off automatically. Automatically, and it can be reset again. Reset again. Can be reset again. While fuse is to be replaced. Is to be replaced. So I'm writing with this stylus, so it is taking too much space. If you are going to write with pen or pencil, it will be taking less time. So, second point you can write that will be that circuit breaker is more sensitive. Trip switch is more sensitive than fuse. So we are done with this question. Moving to next. Moving to next question. So here is a question of magnetism. Figure 7.1 shows a simple DC motor. The poles at the ends of the magnet are not labeled. Only left and right is written. Nothing is labeled here. Okay, we are given split rings and we are given brush. Here is a coil. This is end of magnet 1, end of magnet 2. Here we have axis. So the distance between axis and the edge of the coil is given. Here we have a battery. Okay. So positive terminal is here. It means current is going to flow in this way. So state the purpose of the split ring commutator and brushes. Okay. Split rings, you know why it is used. It reverses it reverses the flow of current. It reverses the flow of current after every half rotation, or you can say after every 180-degree rotation, or after every half revolution. So simple, straightforward. So why we need brushes? Brushes ensures the flow of current, ensures the flow of current in the circuit. So moving next, we have there is an upward force shown on the left side of the coil. You can see the diagram. There is a magnetic field in the space between the ends of the magnet. So state the direction of the magnetic field and you have to tell how you determine this direction. Okay, so see here, this is the upward force and you know current. Okay, Fleming's left hand rule, we have to use the rule here. We know current, conventional current is going in this way. Here the force is downwards and the current is going to be in this way here. So you have to use Fleming's left hand rule. Recall that. Fleming's left hand rule. what it says, that thumb will point force and first finger will represent field, magnetic field, and middle finger, or you can say second finger, will represent current. So what you have to do, you know force, you know this current, and we have to identify magnetic field. So force is upwards. Keep your thumb in the up direction of left hand. Left thumb upwards, and this middle finger should be pointing towards you. It should be pointing towards you, middle finger, or you can say towards you, and then open the first finger. First finger, first finger will be pointing from here left to right. If I do so, if I do so, the first finger is pointing in this side, current is here, and you can see here force is upwards. It is making 90° with this, 90° with this, 90° with this. So force, this is current, and this is going to be field. They must have 90° with each other. So this is your field. So we have to write this, whatever we have discussed here. So direction will be from left to right, from left to right of magnetic field. And explanation is that using Fleming's left hand rule, point the thumb upwards in the direction of force and open the middle finger at an angle of 90° at an angle of 90° towards conventional current, towards conventional current, towards direction of conventional current. I would add here direction of conventional current, and then open first finger at an angle of 90°. It points to field. It points to field. So hope so this is clear. Moving to next part. C part is state what happened to the rotation of the coil if the magnetic field and the current in the coil both are reversed at the same time. So if we make two changes at a time, no change will occur. No change will occur. If we change one, if only magnetic field is changed, magnetic field is changed, or you can say current, then what happens? Rotation reverses. Rotation become opposite. Reverses. दूसरी तरफ rotate होना शुरू कर देगा. Now D part in figure 7.1, the coil is horizontal. Figure 7.1, the coil is horizontal. The force upward on the left side and the force downward on the right side are each 2.3 Newton. So each of them is of 2.3 Newton at a distance. No, sorry, force. 2.3 Newton distance each of them. The distance between the sides of the coil and the axis is 0.15 meter. So you can see here in the diagram, that is 7.1 I show you. You can see here, this is the distance 0.15 between axis and the edge, and this is the force. So we are going to find the total moment here. So total moment exerted on the coil by these forces. So you know moment is equal to force multiplied by distance. So we have to find the total. So 2.3 is the force, 0.15 is distance. So we have to consider both the edges. One way is you simply multiply by 2 or you add them separately like this, plus 2.3 times 0.15. This will give you total moment. And the unit will be, it is Newton, this is going to be in meter, so it will be after calculation 0.69 Newton meter. So the second part of this question is explain why turning effect becomes smaller as the coil becomes more vertical. More vertical. Turning effect decreases when distance decreases from the line of action. So suppose this is a pivot, this is a fixed point. If force is acting here, now if I make this force closer, so distance decreases, moment decreases. If distance decreases, moment decreases. So we will be writing here that the distance, or you can say perpendicular distance between the line of action, distance between the line of action and the axis decreases. So this is one way you can write here. So hope so this is clear. Moving to next question. Okay, this is a question regarding nuclear physics. Figure 8.1 is a diagram of nuclear reactor. You can see control rods, fuel rods, moderator, concrete wall, coolant in air rather than using some gas. There we have container vessel, and we are having coolant out as well. So what we have to do, nuclear fusion occurs within the fuel rods which become hotter as a result. Okay. The thermal energy is transferred to the coolant circulating around the rod. So whenever the fusion reaction occurs, energy is going to be there. So in table 8.1 state the purpose of each part of the reactor. So they have given container vessel. It withstands high pressure and temperature and makes sure no coolant escapes. कूलेंट मूव ना कर जाए आउट सराउंडिंग में मूव ना कर जाए escape ना हो. So what is the purpose of concrete shielding? So you know concrete shielding is for safety precautions for the workers, and it also prevents radiation to penetrate from this. So we will be writing here, it is a safety for workers. It is a safety for workers from the radiation emitted in the core of reactor. So now control rods are basically controlling the number of neutrons, controlling the reaction you can say. So control rods are basically controlling the speed of reaction, controlling the speed of reaction by controlling the number of neutrons. controlling the number of neutrons. So moderator slows down the speed of neutrons. Slows down the speed of neutrons. Slows down the speed of neutrons. So next part is describe what causes fission of single nucleus uranium-235 in the fuel rods. Okay, fission process we have to discuss here and describe what happened during this fission. So fission reaction starts when neutron hits uranium-235. What happens? It splits into two smaller daughter nuclei, and during this further neutrons are going to be released, or you can say more neutrons are emitted, and energy is going to be emitted as well. So we have to write about this. So what happens when one neutron hits or collide with the uranium 235? It splits into two or more smaller nuclei, or you can say daughter nuclei, and during this more neutrons or fission neutrons you can say are emitted. This during this more neutrons are emitted, and fission fragments also released. So we have to write this. It is a simple process. So now we have C part, the specific heat capacity of the coolant is an important quantity in the design of the reactor. State what is meant by specific heat capacity. So here you have to write the statement, you have to write the definition. It's very important. So an amount of energy, what you have to answer here, an amount of energy, thermal energy, or you can say amount of energy required to increase the temperature of per unit mass by per unit temperature. So this is one statement. You can remember much better statement than this statement as well. So suggest and explain whether the coolant should have large or small specific heat capacity. If value of C is high, so it means it has the ability to uh, you can say sustain more energy. So if specific heat capacity is higher, so temperature increase will be smaller because its resistivity for the temperature increases. So what I would be saying here, larger specific heat capacity is required. Larger larger specific heat capacity is needed, so it will not get high temperature coolant will, it means coolant here, coolant will not get high temperature. So this is one way. Or you can say it will take more time for the coolant to get heat up. Or you can say larger specific heat capacity is needed. So more time will be required for the coolant, for the coolant to heat up. For will be more time will be required for the coolant to heat up. So this is also correct. This is also correct. There are many other options. Whatever you like, you can answer. So moving to next question. Okay, question regarding space physics. Figure 9.1 shows the path of a comet, the orbit of the Earth, and the orbit of Jupiter around the Sun. It is, you can see here in the diagram, this is the path of comet, this one, yellow one, and we have path of Jupiter, this green one. Then we have path of Earth, that is this one, and we are having this as a sun. So what they are asking, the comet is at position 3 when the Earth is at position 5. So these are the positions. On figure 9.1, draw the orbits of Mercury and Mars, label each orbit. So we have to draw the diagram here. This is Earth. Here we have comet. So you know Mercury is going to be the closest planet to the Sun. So here it is Mercury, and I label it as Mercury. And then Mars is going to be between Earth and Jupiter. So it is going to be somehow like here. Let me draw. Okay, it's fine. So here is Mars. Mars is between Mercury and Jupiter. Mars is between Mercury and Jupiter. Okay, so explain why the comet at position 3 cannot be seen from Earth when Earth is at position 5. So you can see Sun is in between these two. So Sun is between the Earth and the comet. Simple is this answer. So moving to next part, a force causes the comet to orbit the sun. State the name of the force that acts on the comet. So it is going to be the gravitational force or gravitational field strength of the sun. So simple answer here, no too tricky. So gravitational force of the sun. This is the force. So four positions of comets are shown in figure 9.1. On figure 9.1, mark the direction of force that acts on the comet at each of the four positions. So four positions we have to mark here. You have to go to the diagram. So here we have a diagram. You have this one. Okay, dear students, we are going to draw the four forces. I have cleaned this diagram, removed the other stuff. So one force is going to be in this direction, one from here, from position 2, and one will be from here. This is going to be the direction of four forces. from four different positions. So we are done with this. So we will be looking to another part. We are done with this. So next is describe how the strength of the force that acts on the comet changes as the comet moves from position 1 through position 3 and to position 4. So strength of the force, we have to talk about gravitational field strength. So when the comet is somewhere here, it moves from here till this position 3. When it is going to come to position 3, it is near to sun, so distance is less. Distance between sun and comet decreases. You can see here that this distance is smaller, so field strength is greater. Field strength is greater. So when it moves from here to position 4, field strength decreases, strength of force decreases, and the distance between the sun and the comet increases. So they are inversely proportional to each other. So let's write the statement. Description is as comet moves from position 1 to position 3, strength of force increases. Strength of force increases, while from position 3 to position 4, position 3 to position 4, it decreases. Explanation is that force is inversely proportional to distance. Inversely proportional to distance. So now the last part, that is going to be D. We are going to cover that. Table 9.1 gives the orbital radius and the orbital speed of Earth and Jupiter as each move around the Sun. So you can see here orbital speed and orbital radius is given. Each completes more orbit of the Sun. Sorry, Earth. Earth completes more orbits of the Sun than Jupiter in the same time. Calculate the number of orbits that Earth makes around the Sun in the time that Jupiter makes. So Jupiter makes one orbit, so Earth makes more orbits. So we have to actually calculate that. So we have to calculate the number of orbits Earth makes around the Sun in the time that Jupiter makes one orbit. So first of all, we have to find the time period here, or you can say orbital time period, and we have to find the orbital time period of this, orbital time period of this, and then we have to take the ratio. We will be getting how many orbits will be greater. So we know T is equal to 2 pi r over v. How it comes? We know orbital speed, that is equal to 2 pi r, 2 pi r divided by t. So we will be using this relation. I'm first of all finding for Earth. तो हम पहले टाइम पीरियड ऑफ ऑर्बिटल पीरियड ऑफ अर्थ फाइंड करेंगे. So it will be 2 pi, radius is 1.5, 1.5 times 10 power 8. So 2 pi 1.5 times 10 power 8 divided by 30. So be careful about units. Units should be in same convention. So we will be calculating this. Let me calculate 2 times pi times 1.5 times 10 raised to power 8 and divided by 30. So I am getting 314 times 10 power 5 seconds. So same we will be doing for Jupiter. 2 pi r divided by orbital speed. So 2 pi orbital speed, oh sorry, radius is 7.8 times 10 power 8 divided by 13. So 2 times 3.14 times 7.8 times 10 power 8 divided by 13. So I am getting 3768 times 10 power 5 seconds. So Jupiter time is greater and the time Earth is taking to orbit, it is smaller. So if I draw the diagram, suppose this is Sun, here we have Earth, and in this orbit we are having Jupiter. So it takes one time to orbit. For example, that time is this. And during this time, how many times Earth will rotate or orbit? We have to find this. So what we do, number of orbits is equal to 3768 times 10 power 5 divided by 314 times 10 power 5. So we have to take the ratio here. So 10 power 5, 10 power 5 cancels. So 3768 divided by 314. So it will take 12 orbits. So 12 times Earth is going to orbit, and in that duration, Jupiter is going to orbit once. So hope so this is clear. If you have any doubt, you can ask. And we are done with this paper. Hope so this is going to be benefit. Thank you. Take care.